Hello all, let us look at the operation of a decade counter. This model which is used is HC4017. So decade counter basically is used in many embedded circuits. Like for example, take the case of a LED chaser. So LED chaser is that circuit where the LEDs glow in sequence, right, starting from one point to another, where we are using them for decorative purposes. So we'll see the operation of 4017 here. So before going to the operation, we'll just try to look at the data sheet of 4017. So this is data sheet of from Texas Instruments, and as mentioned here, the basically the operation is that initially all the outputs shall be low. As we say, this is a decade counter. There are 10 outputs. There is a clock, and then clock enable pin, master reset, and then terminal count. So how it operates is on a particular clock rising edge, that is input, the state changes from one count to another. Like example, initially when the reset is removed, the clock on the clock rising edge, the first counter shall be high, and then during the second clock edge, the first one goes low and the second one goes high. So that meant it acts as a counter, and the counter it takes 10 steps, because there are 10 outputs, and then once the cycle is completed, that means the decade count is done, the terminal count output, which is there, goes high to low. So this particular count is required because when we see a chasing circuit, right, it's just not one circuit. We'll have series of LED chaser circuits, and everyone has to operate in sync. So in such cases, to have the second decoder IC, counter IC in sync, this particular input shall be provided as input to the next circuit. So that is how this works. And then there is a clock bar, enable bar. So that means if you keep it low, it operates. So if you see, there is a truth table here which shows how the decade counter works. So the operation that we will consider here is this, where the clock enable is kept low, and then that means because this is active low, that means this is operational, it considers the clock input, and then the master reset is also kept low, and the clock pulse is incremented, so which says that output stage increments the counter. So the circuit starts operating. So that's how this particular counter works. So if you see, there are two series in this. One is HC type, and other one is HCT type. So HC type is a CMOS input logic circuit, and HCT is compatible with TL logic. So that's the difference between HC and HCT logic circuits. And we can see here this operates from 2 to 6 volts of operation, and the maximum frequency at which you can switch is 50 megahertz, which is huge actually. So generally while switching the LED circuits, we don't switch at that frequency. So considering that scenario, these circuits are definitely usable for LED chaser circuits. So now coming back to the circuit which is drawn in MPLAB MINDI. MPLAB MINDI, the input to the clock is provided from a standard circuit. So if you see here, uh, from the model library, if we go to digital and miscellaneous, there is a digital pulse option here. So that meant it gives pulse as required, and then we can place it. And we can adjust the period and with the pulse here. So if you, as mentioned here, if you mention the period as 0, you are going to give only single pulse. Now here what we have considered is we are giving a 1 megahertz clock with zero point 0.5 megahertz as the high and zero point 0.5 megahertz. That means 50% duty cycle, and then we have made RST low and C bar low as mentioned in the truth table of the data sheet. Then the output is terminated with a resistor. So resistor can be taken based on the load, right? Whatever load you have. So we have just kept it blank. And right now, the count, the ternary count is also tied to a resistor just for probing purposes. And now let us try to run the circuit. So what we are going to do is we are just trying to perform a transient analysis here. So choose analysis for 1 millisecond for sample, and then let us try to run the circuit. So once we run, we can see the thing here. Let us just try to zoom in to see how it is functioning, whether it is functioning as we described or not. So if you see here, on every rising edge, so on first rising edge of the clock, Q0 is high. Once the second rising edge of the clock comes up, that means second cycle of the clock is on, Q1 is on, and all the others, Q0 to Q9 except Q1 are high. So you can see the sequence. Imagine how the LED circuits work. And basically this is a divide by 5 counter. So you can see 5 itself, the signal count is high. So this is how the circuit is functioning, and you can see the rising edge of the clock is giving the output on each two of the decade counter. A simple circuit, we have used MPLAB MINDI analog simulator to simulate the circuit, and you can see the pulse. And once the count is done, once the Q9 is done, the TC has gone low, and then on the next clock pulse, you can see Q0. That means the next cycle is up and running. So if you want, you can give this particular signal, whatever we are using, to the next section and operate as required. So a very simple circuit, and nothing complex about it, and used widely in the counter applications. Please let us know if you have any questions. Please post your comments. Please like our video and subscribe to our channel. Thank you.